Hello, good afternoon. I'm Raymond from Project GUHeat, and my presentation is going to be about maps of the project, the tools we used in creating these maps, and I'll also be giving a brief demo on the usage of these tools. So first, here are some output maps of the project. This one is an air temperature map of Lower Session Road in Baguio City. We have three of these maps actually, each one showing a different time step of December 12, 2019. One is at 9 a.m., another at 1 p.m., and the last one at 5 p.m. So what can we do with these maps? Well, one thing these maps can be used for is to provide us with information for decision making and planning. Let's say you want to conduct a greening project to help mitigate the effects of urban heat. One factor you can take into account is which areas would benefit the most from it. As an example, if you look at this map here, these areas in the upper right portion, hold on, these areas in the upper right portion have much warmer temperatures than these areas here. And if you look at the other maps, you'll notice that these areas, this one, they are consistently warmer throughout the day. So based on that, you can say that this area should be the site for the greening project. Um, of course, there's going to be other factors to take into account, but this is just an example. Here's another map created by the project. This time, instead of just air temperature, we have the air temperature difference between two user-defined scenarios. Like the previous one, this map can also be used in decision making, planning, all that stuff. As an example, in this map, scenario one is the current state of Lower Session Road, while scenario two is the same, but with all the trees along the road removed. So this part. We can see from the map that the road with all the trees removed has a relatively high positive value. This means that the air temperature increased when you removed all the trees. So if you're planning on removing all the trees there, well, you can see that this is what's going to happen. This can also be used for other scenarios, such as adding new buildings or even a combination of both, like in this one here, where scenario three is same as scenario one, but some of the open areas in scenario one have been replaced with buildings and some of the pine trees have been removed. I think this was already discussed earlier by Alvin. And this is just another output. This time it's a different area. It's Upper Session Road. Okay, so this is another map by the project. This is a built-up expansion map of Baguio City. And with this, you can see how much the built-up portion of the city has grown in 6 years, 2012 to 2018. This growth may be linked to other matters such as increase in temperature, population growth, etc. And last map by the project for now is this LST time series map. Here we can see the trend of temperature throughout the year. We can see how the temperature in Baguio City increases from February to April and then decreases in December. You can add more images or time steps to produce a more accurate trend. Okay, so now we discuss the tools used. So we have three main tools used in the project: Google Earth Engine, GUHeat Toolbox, and ENVIMET. So the first one is Google Earth Engine. Google Earth Engine is a cloud-based computing platform which also has access to a huge database of satellite images. So pros and cons. Like I said, it has access to a lot of satellite images, free satellite images, by the way. So there's no need to download the images before processing. Uh, it is also cloud-based, so most of the processing is done on Google servers. This alleviates the computational load on the user's PC, meaning even older PCs will be able to produce good output, and processing times are usually much faster than if you're using your own, and then if you're doing your processing on your own machine. However, also because it's cloud-based, an internet connection is required. And it is also necessary to know how to code in Python or JavaScript in order to make full use of it. You can use Earth Engine apps created by other users, but you'll still need to know how to code if you need to make any changes. Also, there are cases where an API update breaks the code. In this case, you'll need to know how to code to fix it. Okay, so this is just going to be a short demo on how to use the Project GUHeat Google Earth Engine app. First, you have to open your browser, and in the address bar, you enter this URL, then you press enter. So here we can see the GUHeat engine. It is an Earth Engine app created by the project. And what it does is it automates the land surface temperature computation using Landsat images. So to start, you first select what satellite you want to use. You can use Landsat 4, 5, 7, or 8. For this demo, we'll just use Landsat 8. And then you select whether you want to use day or night images. After that, you'll see that the app will load in this new layer. This layer just shows the Landsat tile footprints over the Philippines that are available. You can click any of these tiles to automatically set the path and row field here of the area that you just clicked. So since I clicked this tile containing Metro Manila, it set the path and row to 11650. After that, you can set the start and end date that you want to process. So for this demo, we'll just set the start date to January 1 and the end date to January 31. Then once that's done, you click Generate LST. So after a few seconds, the outputs should be loaded here. There we go. So as you can see, there are 2 dates available. You can also see the dates here in the list of layers. So we have one image that was taken January 4, 2019, and the other one was taken January 20. You can also turn these layers on or off if you want to check which image is better. Now to export, you can either use select on map the area that you want to export, or you can use view extents. So first, I'll show you what this does. So using view extent just sets the export area to the whole view extent, basically. But for now, we'll use select on map since we only need a small area. So once you click the button, you can draw a rectangle over the area that you want to export. Then you'll see that stored here as this layer called export extents. You can turn off some of the layers to make it faster. And then once you're done with that, you can click generate links. After a few seconds, it should show here we go, a list of download links here. So this image that we're showing right now is the one from January 4. So let's download that. So after downloading, you'll have this TIFF file. You can open this in any GIS software really. So let's open this in QGIS, and there you have it, an LST image. This is the one from earlier, the area that you selected earlier. That's it. So next is the GUHeat Toolbox. The Toolbox is a plugin for QGIS created by the project as an alternative to Google Earth Engine. But Other than computing for LSD, it has other tools included in it which the project uses for processing other stuff. So pros. Oops. Pros. It is relatively more stable than Google Earth Engine, as updates usually don't change much, and especially if you're using a long-term release version. Also, internet connection is not required. So you can just download the images when you have internet and then just process them after. However, since you're doing the processing on your laptop or on your machine, the processing time would depend mainly on your machine specs. And most probably your machine isn't going to be as powerful as Google servers, so processing could take much longer. For comparison, processing a single Landsat tile in Google Earth Engine usually takes a few seconds, while processing the same tile on my laptop can take a few minutes. It might not be that big of a difference, but if you're processing a lot of images, then those small differences tend to pile up. Also, same with Google Earth Engine, you also need to know how to code to make the plugins and to do maintenance if something goes wrong. So now we'll be looking at the Project GUHeat toolbox. So after installing the toolbox, you can see it here in the menu bar of QGIS. So here are the available tools. For this demo, we'll just be using the land surface temperature. So we're going to be processing a Landsat 8-day image. There's only going to be one image, so we'll just set this to individual data. Like with the Earth engine, the GUHeat engine, you can also process Landsat 4, 5, 7 images. So first, you set the input path. This path is just going to be this folder. This folder contains the Landsat bands after extracting. So we set the input path to that. And then for the output path, you just set the path the folder where you want to save the output. And for the output file name, you just put the output file name. You can also turn on show results to automatically load the output into QGIS. So let's turn that on and then you press run. So after a few minutes, you'll see the output image loaded into QGIS. You can now close this window. So in order to properly visualize the land surface temperature, you can double click the layer here and go to the symbology menu, and then you change the render type to single band pseudocolor. And then here in the band, you can select band 6, which is land surface temperature. So there are other bands that you can display, but for now, we'll just show land surface temperature. You can also change the color wrap if you want. And you can also change the mode here to make it easier to visualize. So we'll use quantile and you can increase or decrease the number of classes. Then you just click apply and OK. So there you have it. This is the processed LST image. The yellowish parts correspond to higher temperatures, while the purple and pink-ish parts correspond to lower temperatures. That's it. So the third tool is ENVIMET. ENVIMET is different from the other two in that it is a simulation software. So with ENVIMET, you provide it with a model of the area. Usually, this model includes buildings, vegetation, land cover, etc. This image right here is an example of an input model for ENVIMET. The gray blocks represent buildings. The green spheres, double quote, represent tree canopies, while the color of the surface represents the surface material. So in this case, the orange-brown surfaces represent soil or dirt, while the light yellow surfaces represent sand. You also provide ENVIMET with atmospheric parameters such as air temperature, relative humidity, and wind speed, wind direction. The software then takes all this data and it simulates the microclimate condition in the area. This simulation can then be used to analyze the effects of the structures and objects in the area on the environmental factors such as temperature, wind direction, wind speed. There's a long list. Um, One of the outputs of this simulation is this map, which was actually shown earlier. So in this map, you can see air temperature. You can also see the wind direction represented by these arrows. Um, so yeah, these are just two of the many available simulation outputs when you use ENVIMET. There's a lot of them really. Yeah, that's it. Okay, so just a few more announcements. The GUHeat toolbox and access to the GUHeat engine will be provided during the closing seminar on August 14. Soft copies of the maps will also be available then. And if you have other concerns, questions, you can send us an email on projectguheat@gmail.com. And that's the end of my presentation. Thank you.